Hi everyone, this video is about my own summary for chapter 9 that is entitled as the transport layer. This chapter is about the transport layer. Transport layer is in OSI model, it defines services to segment, transfer and reassemble the data for individual communications between end devices. But in TCP or IP model, it supports communication between various devices across diverse networks. The transport layer is responsible for establishing a temporary communication session between the two applications and delivering data between them. It moves data between applications on devices in the network. At the transport layer, each set of data flowing between the source application and the destination is known as a conversation. The responsibility of the transport layer is to maintain and track these multiple conversations. Data must be prepared to be sent across the media in manageable pieces. Most networks have a limitation on the amount of data that can be included in a single packet. The transport layer protocol have services that segment the application data into blocks that are an appropriate size. At the destination, the transport layer must be able to reconstruct the pieces of data in a complete data stream that is useful to the application layer. So, the protocols at the transport layer describe how the transport layer header information is used to reassemble the data pieces into streams to be passed to the application layer. So to pass the data streams to the proper applications, the transport layer must identify the target application. So to accomplish this, the transport layer assigns each application an identifier that is called a port number. Segmentation allows conversation multiplexing which applications can use the network at the same time. Segmentation facilitates data transport by the lower network layers. Sending some types of data across a network as one complete communication stream can consume all of the available bandwidth. This will then prevent other communications occurring from occurring at the same time. So it would also make an error recovery and retransmission of damaged data difficult. So error checking can be performed on the data in the segment to check if the segment was changed during transmission. So to identify each segment of data, the transport layer adds a header containing the binary data organized into several fields. It is the values in these fields that enable various transport layer protocols to perform different functions in managing data communication. So the transport layer is also responsible for managing reliability requirements of a conversation. Different applications have different transport reliability requirements. Transport protocols specify how to transfer messages between hosts. The TCP or the IP provides two transport layer protocols, that is the Transmission Control Protocol, or also known as the TCP, and the User Datagram Protocol, that is also known as the UDP. IP uses these transport protocols to enable hosts to communicate and transfer data. TCP is considered a reliable, full-featured transport layer protocol, which ensures that all of the data arrives at the destination. However, this requires additional fields in the TCP header, which increases the size of the packet and also increases delay. In contrast, UDP is a simpler transport layer protocol that does not provide for reliability. It therefore has fewer fields and is faster than the TCP. So TCP transport is equivalent to sending packages that are tracked from source to destination. If a shipping order is broken up into the several packages, a customer can check online to see the order of the delivery. While in the TCP reliability functions, it provides more robust communication between the applications. They also incur additional overhead and possible delays in transmission. There is a trade-off between the value of reliability and the burden it takes in it places on network resources. Adding overhead to ensure reliability for some applications could reduce the usefulness of the application and even be detrimental. So, in such cases, the UDP is better. UDP is a better transport protocol. UDP provides the basic functions for delivering data segments between the appropriate applications, with very little overhead and data checking. And also, UDP is known as the best effort delivery protocol. In the context of networking, best effort delivery is referred to as unreliable because there is no acknowledgement that the data is received at the destination. So with the UDP or the user datagram protocol, there are no transport layer processes that inform the sender of a successful delivery. For particular applications, segments must arrive in a very specific sequence to be processed successfully. With other applications, all data must be fully received before any is considered useful. If there is any missing data, it could cause a corrupt communication that is either incomplete or unreadable. These applications are designed to use TCP. In other cases, an application can tolerate some data loss during the transmission over the network, but delays in transmission are unacceptable. The UDP is the better choice for these applications because fewer networks overhead is required. In Transport Layer Protocol, the UDP and the TCP has a required protocol properties, where for the UDP it must be fast, low overhead, does not require acknowledgement, and does not resend the lost data and delivers data as it arrives. While for the TCP, it must be reliable, acknowledges data, resends lost data, and delivers data in sequence order. In short, the properties required for TCP is the reverse required properties for the UDP. To understand the differences between the TCP and the UDP, it is important to understand how each protocol implements specific reliability features and how they track conversations. In addition to these, the TCP services provide an establishing session, same order delivery, reliable delivery, and also flow control. So TCP is a stateful protocol. A stateful protocol is a protocol that keeps track of the state of the communication session. To track the state of a session, TCP records which information it has sent and which information has been acknowledged. The stateful session begins with the session establishment and ends when closed with the session termination. So the user datagram protocol or the UDP is considered a best effort transport protocol. UDP is a lightweight transport protocol that offers the same data segmentation and reassembly as TCP. But without the TCP reliability and flow control, the UDP is such a simple protocol that is usually described in terms of what it does not do compared to the TCP. UDP features includes the data reconstructed in the order that is received, any segments lost are not resent, no session establishment, and it does not inform the sender about the resource availability. So UDP is a stateless protocol, meaning neither the client nor the server is obligated to keep track of the state of the communication session. If reliability is required when using the UDP as the transport protocol, it must be handled by the application. TCP and UDP manage multiple simultaneous conversations by using header fields that can uniquely identify applications. These unique identifiers are the port numbers. The source port number is associated with the originating application on the local host. The destination port number is associated with the destination application on the remote host. So the source and the destination ports are placed within the segment. The segments are then encapsulated within an IP packet. The IP packet contains the IP address of the source and the destination. So the socket is used to identify the server and service being requested by the client. Sockets enable multiple processes running on a client to distinguish themselves from each other and multiple connections to a server process to be distinguished from each other. And the segment sequence numbers indicate how to reassemble and reorder received segments. TCP also provides mechanisms for flow control. The amount of data that the destination can receive and process reliably. Flow control helps maintain the reliability of the TCP transmission by adjusting the rate of the data flow between the source and the destination for a given session. When congestion occurs on a network, it results in packets being discarded by the overloaded router. When packets containing the TCP segments don't reach their destination, they are left acknowledged. The UDP provides the low overhead data transport because it has a small datagram header and no network management traffic. The transport layer tracks each individual conversation flowing between a source application and a destination application separately, and it divides the data into segments that are easier to manage and transport. It ensures that even with multiple applications running on a device, all applications receive the correct data. The TCP is a great example of how the different layers of the TCP and IP protocols should have specific roles. So that's all, and thank you for watching this video, and I hope you enjoy and understand my video. So I'm Kisha Lyka Villanueva of IT 2105.